We were talking last time about the November 13, 1833 Leonid meteor shower, in which it looked like the whole sky was falling. And this is really the most famous of all meteor showers, or the Leonid meteors. They look like they come from the constellation Leonid. We talked about how Dennis and Olmsted figured out that because of that, they had to be extraterrestrial in origin. And then Olbers and Newton calculated there was a 33-year cycle, and that there's a swarm that comes by, and about every 33 years, Earth passes through that swarm, and you get a meteor storm. And so it's about every 33 years. Now, this swarm, it can be affected by other things. Remember, you're going in this big orbit out here, and you've got Jupiter and other planets that are out here tugging on that swarm. And so that actually can change the orbit slightly. And so it's not exactly every 33 years. Sometimes the swarm misses Earth. Sometimes it clips Earth. Sometimes it moves it a little bit early or late. So, for example, in 1833, it was a spectacular meteor shower. In 1866, everybody went out to watch this, another meteor storm, and it was a good meteor shower, but it was not a meteor storm. It was a pretty good meteor shower, on the likes of which was somewhat better than the other best meteor shower of the year, but only somewhat. You were still only getting a meteor about every 30 or 40 seconds, not like several per second. And then in 1899, everybody was out, eagerly ready to watch, and they pretty much had, played this up as to how spectacular it was going to be, and complete dud. Nothing happened in 1899. And so hardly anybody was looking in 1900 when you actually had another meteor storm. And so then 1933, people were expecting a pretty good meteor shower, got nothing, the complete dud. And then in 1966, so 1933 was a dud. 1966, I was too young to actually, be out observing at the time. And didn't even know about meteor showers at the time. And amateur astronomers I've talked to, or professional astronomers even, that saw the event in 1966, they still, it's just like, it was all inspiring, because they said, you became dizzy. You felt like, you were looking up and you get feeling like you were moving, because of all the sky shifting. Again, it was a meteor shower of the likes of the 1833 one, and it was spectacular. So Leonids, ever since I started in astronomy, the Leonids were this famous sort of thing, and everybody was looking forward to the next one. So that was going to be 1999, and then, but by that point we started getting to where we understand orbits a lot better, about how these swarms worked, and so they started predicting what might actually not be 1999. This might actually be closer to about 2000, but they said that activity would really pick up starting in 1998. And so I remember did a field trip with a bunch of students to a state park, and that night, starting just about 12:30 in the morning or so, all of a sudden these giant fireballs started flying across the sky, coming away from the constellation Leo. And it was really spectacular. It was about a fireball every 2 minutes. So this was a really good meteor shower. Okay. 2000 was going to be the massive peak, and went out again with some students. We were out at the park, and the events were supposed to start picking up about 12:30 or 1 o'clock, and what happened was clouds rolled in about midnight, and there were thin clouds, so you could actually look up and see flashing in the clouds. It was not lightning, it was the meteors above there. So it was a meteor storm, we just did not get to see it where we were here in North Texas. And 2001 was a pretty active shower too, and then it kind of died off after that. That's kind of what was going on. The next question is, where does that swarm come from? How do you get a, well, the thing is, right before the 1866 event, in 1862, Lewis Swift and Horace Tuttle discovered a comet. Astronomer John Couch Adams, this is not President John Adams, this is John Couch Adams, British astronomer, calculated that the orbit of the comet matched that of the Leonid meteor shower. So this led to the idea that comets, as they swing by the sun, and remember what's going on with the comet, you know, you've got the sun here, and then you've got the comet, and the orbit of the comet comes by, and as the comet is here, you've got the tail coming off, you've got the ion tail, but you also got the dust tail. Now, what's the dust tail? The dust tail is the dust and particles blown off by the comet, you know, as it's outgassing, and the light pressure pushes things into an orbit that follows along about the same orbit as the comet. And so these dust grains, some of which are like, you know, sand grain size, they keep following in an orbit very similar to that of the original comet. And then if Earth happens to be on an orbit that passes through a swarm of those grains, that gives you a meteor shower. So this is where the idea came about as to where meteor showers come from. And so Comet Swift-Tuttle turned out to be the origin of the swarm that makes the meteor shower that we call the Leonid meteors. Other meteor showers are associated with other things. For example, in August, that's the comet Tempel-Tuttle is associated with the meteor shower that happens then, the Perseid meteors. The Orionid meteors are actually associated with Halley's Comet. And so there's a variety of these meteor showers that we can identify the comet that they're associated with. So Earth passes the swarm, you get a meteor shower. Now, the thing is, as Earth is passing through the swarm, the front side of the Earth is what gets most of the meteors. Well, what's the front side of the Earth? Well, as Earth is rotating, that's going to be from local midnight till local noon. Local midnight is not midnight according to the clock. Local midnight is going to be midnight according to local mean time. So that means it's about 12:30 a.m. if we're on standard time here in North Texas. It's about 1:30 a.m. if we're on daylight time here in North Texas. Now that's a little bit off because sometimes these meteor showers come from a very inclined orbit, and so sometimes that can be a little early, a little bit late, depending on exactly where the radiant is. Activity does start picking up as soon as the radiant rises above the horizon. This is true for most meteor showers. There's a couple of meteor showers in the summer that the meteors are actually catching up on Earth from behind, and so it's the backside of the Earth. So that'd be from noon till midnight. Well, remember, midnight till noon, you can't really see them after sunrise, so the best time to see meteor showers is normally a couple hours before sunrise. That's your ideal meteor shower time. Okay, so what about the meteors that are Leonids? You know, 33-year cycle. The last one was delayed a little bit, so 2000 was the peak. And what about 2033? No. What happened was the 2033 is going to pass just inward of Earth's orbit, and it's going to be a pretty, you know, it might be a little bit more active than normal, but it's probably going to be kind of like the 1933 dud. Okay. 2066 might be okay, but that'll be the last time it'll ever happen. After that, Jupiter's gravity is going to shift the meteoroid stream orbit. It will no longer actually cross Earth's orbit. So after that, there'll be no more Leonid meteors, and definitely no more Leonid meteor storms. And so you might say, oh, wait, I missed all that. Okay, that's okay, because there are possibly other meteor storms that are out there that might get shifted into running into Earth. And every now and then a new meteor shower happens, a new annual meteor shower, or just a stray meteor shower, or something. It's not very often, but every now and then something new does happen out there. I want to also point out that the December meteors, the Gemini meteors, which are like mid-December, there's actually no comet at all associated with them. Instead, it's the asteroid 3200 Phaethon. Phaethon is actually a carbonaceous asteroid. So this is an asteroid that we think is very rich in carbon organic molecules, and Phaethon has this really weird, very elliptical orbit like a comet. Well, in fact, we think Phaethon might actually be an extinct comet. That after you got rid of all the gases, what's left is the rock and carbonaceous and organic, carbonaceous material, organic molecules, and so forth. And so Phaethon may be actually an extinct comet. And so the Gemini meteors are associated with that. So how do you observe meteor showers? You go out and look up. You're best going out with friends and looking up, because if you're up at 2 in the morning and just looking up, you tend to like fall asleep. You don't want to just stand and look up. It's more comfortable to lay down and on a recline or something looking up. So that's your best way of doing meteor showers. The best time is between local midnight and dawn. Okay, for most meteor showers, not all. And then sometimes if it's cloudy, what will happen is that the meteor is above the clouds, it ionizes air, and so what will happen is a radio station over the horizon will bounce off of that and then come back down, and you can pick that up. So just a little portable radio, and I've done that before too, is during the meteor shower where we couldn't actually see the meteors, and I knew they were happening above the clouds. I tuned a radio to a radio station in Houston, an FM station. Now, FM does not bounce off the ionosphere the way AM does, so there's no way of detecting an FM station over the horizon unless there's a meteor over central Texas. And then for a second or two, the radio signal will reflect off of that meteor stream, the ionized gas, before the meteor hit the atmosphere. And so what can happen is you tune a radio to an FM station that's over the horizon that you cannot normally pick up, and during a meteor shower, you know, what will happen is once in a while, for a second or two, you'll suddenly get a little bit of signal from that station, and then it goes away again as the ionization trail dissipates. And so that's one way of actually picking up meteors that you can't even see.